Okay guys, so this is the tutorial for dynamic joint chains in MotionBuilder. So import your bone hierarchy. I have one set up here, and it's a relatively easy setup. It's just for testing. Then first thing we need to do is we need to go to our asset browser, and under elements just open the little cross here, and under elements you got a category called primitives, and in primitives you have polysphere. So drag that into the scene and place it inside one joint, for example the first one. Scale it down like this. I'm just gonna show my x-ray just to see where my bones are through the geometry. Now that we got one polysphere, I will control C, use Control C and Control V to copy and paste it inside the scene, and then I will align it with with all the other bones. So it's align, translation, all. Again, Control C, Control V. I'm holding X because I'm using Maya's interaction mode. So okay, so it's X, holding down and placing it inside the bone, and then align, translation, and all. Again, Control C, V, X. And then I will add additional one just because it works better if you just add another one as an end to your dynamic joint chain. Don't ask me why it works better, it just does. Okay, so now that we have these polyspheres, we will use them for rigid body as a rigid body objects. And second thing we need to do is we need to go to elements under the asset browser, and we just need to navigate and find null, drag it in the scene as well, the same procedure as with polyspheres. Drag it inside the joint socket and scale it down and repeat the process. Okay, so this looks okay, I guess. So now the next thing, oh so shit, I kinda messed up here because I aligned it incorrectly, so I will try to do it correct this time. Right, that's good. So what we need to do next is, as a third step, is we need to create rigid body objects on top of these polyspheres. So you do that by going into physical properties, and you'll be able to see the joint, ragdoll, and rigid body options. So just take one rigid body, just take it and place it inside the first polysphere, because it will be a parent of your chain. So just do it like this on top of the sphere, and it will show you the properties of the rigid body. See, in the navigator you will see this window, this central window here, and from rigid body activation you need to put it on passive because it's not going to move. And then approximation setup, you can leave the approximation setup on correct mass center on. Then Second step is just select all the other spheres in the scenes that you have, and you will add additional rigid body to them, but it will be the same rigid body, so they will share the properties. Okay, so this is a rigid body 1, and original body is rigid body. So just to be like clean, I'll rename it RB 1, and the second one is RB2. Okay, so on the second one, these guys or everybody else should be active, so activation is can remain inactive. And approximation setup, you need to remove the correct mass center from all the other spheres, so just remove it here. Okay. Okay, so now what we need to do is we need to add bones or joints to the nulls, and you do that pretty easy. It's a straightforward procedure. Just select all the nulls from top to bottom like this. I like to use my navigator for this because it's kind of tricky to place them by dragging. So I will take my joint and drag it inside the navigator on top of the first null. It will show you the joint all properties, and under joint objects you have null joint 1, 2, 3, 4, 5, 6. Okay, so these joints are actually invisible, I guess. You don't see them, but they are pointing straight down because you didn't move, or you didn't change the rotation of these nulls. They're pretty straight. So what we need to do now is we need to assign the controllers for the joints that we just added. And controllers for these joints are actually polyspheres that we created earlier. And so the logic behind this is you need to select the first sphere that will be parent to the child of your chain. So this is the first one. The second one, order is really important here, and then just drag it, so by holding X, drag it inside this null joint connections, and that's it. That's for the first joint connection. Second joint connection is this would be the parent of the third polysphere, so the second would be the parent of the third. You do the same thing, but just under null 1. Okay, so now 1, now 2. Third will be the parent of the fourth, and so on. Okay, and for the for the last one, you see you don't have any spheres to add, and you don't have any nulls down there. So for the last one, what I like to do is I usually pick the second from the end and the end sphere. So this will be the parent of this child, and then I add it to the last joint object. Okay. Sorry. So now we should be able to see the simulation, I guess, if it works, if it worked correctly, if we did everything correctly. So just go to your asset browser, find the find the option called solvers, and under solvers you have physics solver. Drag it inside the scene and just tick online and tick live, and this is it, I guess. Yeah, it's working. You have the simulation for your cloth or whatever. I don't know, you can just use it for everything, I guess. It's really helpful for games and yeah, game production, or even movie production. Yeah, so what I like to do next is just to show you how it will control this hierarchy that I've imported. Is just untick live, untick recording, reset to start. I will just bring it back to the initial position, and just kill the online button. So now physics solver is not really calculating anymore. Now next thing to do is we need to add constraints to these bones, and we will constrain them to the spheres. So under constraints, under asset browser, find constraints option and scroll down to the position constraint. Position constraint is I find the most non-destructive way of doing things here. So just pick it, drag it inside the scene on top of the first joint, and just say constrain object, and then pick the first sphere above it, X drop or X drag it inside this source one slot, and hit snap, because snap will allow them to remain on their positions even though they are aligned. But let's say, for example, if they weren't aligned, they would still remain on the same positions, but be constrained after this activation. So always use snap for these things. Okay, so we do this for the next joint as well. Constrain, polysphere above it, and snap, constrain, polysphere. Wait, sorry, I think I did something wrong here. Wait just a second. Okay, so yeah, okay, so I guess something went wrong here with my machine for some reason. I'll just continue and try to do it like this. So constrain object, snap, oh. Sorry, constrain object, snap, and then we will constrain this joint end to this sphere. I hit snap. Okay, so now if we go to solvers, physical solver, place it online, and pick your sphere, you should be able to see it working. Yeah, it does. The cool thing about this is it's not really recording scale, and sometimes you don't really need it. So you can see that there's no scale changes inside the F curves for each and every joint. So scale remained on 1 as a 100% as an initial value that we had, and when you are moving it, it's just recording the position, even though it is scaling them. It's not really scaling joints, it's just moving the position of the nulls, and joints are being updated by that, I guess. So yeah, that's a quick and easy way to do dynamic joint chain inside the MotionBuilder for your cloud simulations and whatever. You can just play when you're done with that. You can go to your just kill your physics solver calculations, because you can't really do anything while they're on. I mean, you can't really change any properties. So go to your rigid body properties, and you can just adjust some of the density, friction options here. Bounce could be like, I don't know, something. You can just play around with that, and if you are when you're happy with that, with the results, go to the physics solver and see what you did. Sometimes it works, sometimes, I mean, changes are relatively small sometimes, so you won't be able to see, but you need to test it out. Thank you guys for watching. I'm out.